Hello and welcome to the Chapter 13 lecture video. I'm not going to do a hint video because I've given you start code in Blackboard as well as a PDF that will tell you everything you need to know. The rest of it you can figure out on your own. It's not that bad. Just make sure that you read and follow the directions thoroughly, because if you don't, you're just going to have to fix it again. So it's up to you. At some point, I'm going to have to stop allowing resubmissions because we're running out of time in the semester. We only have 3 more weeks. So, of course, hopefully you'll be working on the extra credit project, which is a real challenge, but I would highly recommend that you at least attempt it. It kind of pulls together everything we've learned. All right, so here's some little project that I've created. And obviously, Chapter 13 deals with strings and string functions. And let me say up front, the only way to really learn how to use these is to learn how to use them, because there's a lot of overlap. There's more than one way to skin a cat, as it were. There are a bunch of different functions that overlap. Before we get into that, let me remind you what I said about strings, because there was a time when we didn't have a string class. We had to dynamically allocate memory and deallocate memory and create an array of characters, grab the string from the input string or the keyboard or wherever we're getting it from, and resize the character array to fit the new string. And so this was all done behind the scenes, and we created our own string class. So what I'm getting at is a string is nothing more than an array of characters. Because it's an array of characters, you can iterate through that array and look at each character, which is kind of neat because that helps you get a long way toward the cipher machine project for 13, the Caesar cipher. Okay. Before we get started, let me show you a little something here. I've got start 65, stop 90. That's ASCII capital A to ASCII capital Z in the ASCII code, which is now Unicode. All right. So there's a couple of things I can do. The first thing you can do is you can declare a loop control variable of type char, set it to A, and set it to the condition less than or equal to Z, and then increment it by 1. It will automatically know that that's an ASCII value, and it will automatically increment C as a char through A to Z. All right. Also, you can go ahead and explicitly say I want to use an integer of start, which is 65, and less than or equal to stop, which is 90. That's A through Z, and I'm incrementing it. And I'm casting it using static cast of type char, that ASCII value, into a character before I output it. So let's run this, and I'll show you they produce exactly the same output, but this is kind of neat. So other languages won't really let you do this. Let's see. When I say other languages, I mean, Visual Basic, .NET, and C#, those kind of things. And the slow computer will eventually get rolling here. All right. So if I run, let me hit F5 here. That took me through that loop. Let me show you the output. A through Z, all capital letters, right? Using nothing but a character. And I think I just went beyond where I was supposed to go. Oh, there it is. All right. So there's the second loop, right? Just using an I and casting each ASCII value to a character. And you can go the other direction too. You can grab an ASCII character and extract its ASCII value in the form of an integer. All right. So that's something you might want to know. So there's those 2 loops. And the next thing the book talks about is CN. All right. If you want to get a value or a string or a paragraph from a user, you're going to have to use getLine. All right, because as soon as you hit the enter key, it's going to take that as the end of the input, like we've been doing. So getLine CN, it's basically using the CN function, and I'm storing it in string input, which is a string that I declared up here, right? And it's saying get this line as long as you don't encounter a new line or a return or an enter key, right? when you encounter that, that's the end of it. Okay, so I'm going to type this as a test to the screen. Hopefully. Okay, this is a test, exclamation point. All right, so it grabbed that, and when I hit enter, it went down here and hit this C out and just outputted what I just inputted. So you can see that it basically stops here. Now there's an ignore component to this. You can tell it to ignore certain characters and do different things, but that's sort of a subset of getLine. I'll let you read that on your own. That one's not all that important. Okay, so now we're at the length function. And these are all methods of the string object, all right? And they are invoked by using the dot operator. So if you have a string character, a string type, and you've called it, declared it, and initialized it, and you put a dot operator on it, IntelliSense will show you all of the methods and properties associated with that object. And there's a bunch of them. I'm just hitting the highlight ones, the ones in the book, but you can see there's append, assign, CN. I mean, there's all sorts of things here. If I type an L, that'll take me down to the L's, and there's length, right? Now, what length gives you, let me delete this. It gives you the number of characters in the string, all right? Remember the off by one error we talk about? Whenever you're iterating through an array, you always start at index 0 because a string is an array. So you wanted to go, you could say I less than or equal to string.length minus 1, or you can just say I less than string.length. That'll take you to one less than the number of characters in the string, which you have to do or you'll get out of array index error. All right, so it's always one less, and the highest index is always one less than the number of characters in the string, or the number of elements in the array, as it were. All right, so here we are, and what this does is it starts with this string, starts at index I, which starts out at 0, right? Remember the arrays. And it just keeps looping and incrementing I, so it's going to examine every character in that string and output it, right? So if I were to do that with F10, let's see what it does. Whoop, recompiling. Sorry about that. I made a change and had to recompile it on the fly. See what it's doing? It's outputting every character in that string. Now, why this is important is you may need to convert that character to its ASCII component and examine it or do something to it. Hint, hint, your project 13. And I've given you some code for that. I mean, I'm not asking you to do it all from scratch. I'm going to go ahead and hit F5 and continue on. And let's see what we have. So it basically outputted everything in the string. Okay. Now we're going to look at substring. This is kind of neat because what you're looking for is a particular character at a particular index, right? So let's see what substring just returned. This is a test 5.2. Is, all right, because 0, 1, 2, 3, 4, 5. It starts at 5 because I told it to, and it returned 2 characters, 1, 2, all right? You always start at 0 index, and that's what it did. It says start at 5 and return 2 characters. All right, now you may be grabbing those out of a string. You may be looking for something in a string to make sure it's there. Now here's find. This is pretty cool because it will return if it finds a given character in a string. And this is telling it to start at the 0th index at the first location. You could tell it to start if you knew where something might actually occur in a string. You could give it that index and it wouldn't have to start at 0. But I don't know where it is, so the word A can be found starting at subscript, and so it's going to output where A can be found. Now, the thing to remember about some of these functions, if it returns an index and it's looking for something, but it doesn't find it, it's going to return a -1, okay, because there is no -1 position in a string. It could just as easily be -20, but they use -1. So if it didn't find A here, it would just return a -1. But it's going to find it, and it's also going to find the word wish. Now here I've started at 0, and here I've started at 0, assuming we didn't know where to start. So we started at the beginning of the string. So let me hit these and go on through, and let's see what we get. The word A can be found starting at subscript 8, right? So, and then I changed the, let me get back up here. This is a different, these are just different strings. So you could count them up if you wanted to. 0, 1, 2, 3, 4, 5, 6, 7, 8. Right there. Okay. And then this wish starts, it found wish somewhere. Let's see. Erase is another one that I actually skipped over. I'm sorry about that. I keep clicking on these breakpoints. Wish can be found starting at subscript -1. Huh. How about that? That's because there is no wish in this string that we're examining. And we are examining string.input. String.input is this. This is a test. So I got a -1 for wish because wish wasn't found. Found A at subscript 8. All right. Now the erase function actually jumped over it, already outputted. But it's going to erase at substring 8. It's not the erase, that's the substring function. Sorry about that. Got the wrong thing in there. You'll have to look that one up. But it basically just removes characters out of a string at a certain location and a certain number of characters. So it would be erase, not substring, and it would have the starting location and the number of characters, just like find does. So that's my bad. Replace. All right. So I reinitialize string input here. This is a test. And then I'm going to replace starting at 0, 8 characters. 1, 2, 3, 4, 5, 6, 7, 8, including a space. So this is a test, should be I want a test. Let's see if that's what happens here. And let's go out. Yep, see what it did? Okay. Insert, as opposed to erase up here, erase will make the size of the string smaller because it erases characters out of it. Insert actually inserts characters into it without erasing anything or overriding anything, so that makes your string bigger. Okay. So instead of I want a test, I want to insert I don't want a test. So let's press F5. And here it is, I don't want a test. So you see how these work. They're not that bad. And assign means I can actually, and there are some instances where you want to initialize the string to a bunch of characters. All right. And this is how you do it. Assign, it takes the length of the character, of the length of the string, and initializes it in this case with asterisks. So there would be a bunch of those. There's times when you want to do that. Like if you're getting passwords, you're playing Hangman, writing a Hangman game, those sorts of things. Now, you've already seen concatenation. I just want to go over it with you again. It means joining a string. So here's first name, John, last name, McGee, string full equals string first plus a space plus string last. Plus is an overridden operator. It's not using math in this case. It's used for strings just to join one to another. All three of these are strings. This is just a space. So then at the end, it's going to show us, hopefully, the full name. John McGee. There it is, folks. And the only way to do it is just to use them. You know, play with them. That's the way it works. And I think you'll find these pretty useful. I actually may assign another chapter depending on how things go. But you do need some time to work on that extra credit. So you may not get another chapter. But I do want everybody to attempt it and let me look at it, and I'll help you with it. But I've given you quite a lot in that file, that .c++ file that I've posted in Blackboard. There's only a few things you have to do. Now remember, you have to create a method or function and call that to encrypt and decrypt. All right. So that's all I'll tell you about Project 13. It's pretty intuitive, I think. All right. Have a good one.